Good afternoon, and sorry for the delay in the start. Let's begin this session. So we are New Jersey Unified Communication User Group, and this is the lunchtime session. I hope you're enjoying your lunch as well as my session. Um, all right. So today's session. Okay. Today's session is about transport architecture and mail delivery in Exchange 2013. Something about me. Myself, Prabhat Nigam. I'm a Microsoft MVP for Exchange Server. I write my blogs on msexchangeguru.com. I'm a Microsoft Certified Solution Expert for Exchange 2013 and MCITP for Exchange 2010 and 2007. I have worked for Microsoft Exchange PSS for 2 years, and currently I work on consulting in Exchange and Active Directory projects. Alright, let's move on to the agenda. So the agenda of the day is new transport architecture, transport services and ports, mail delivery, receive header, transport connectors, transport high availability, shadow redundancy and safety net, shadow redundancy workflow, transport high availability workflow, and routing. All right, so starting with architecture. So Exchange 2013 has come up with a new Exchange transport architecture, which is going to make it pretty easy for Exchange to deliver the messages and give the more high availability. So we'll start with client access server. So client access server can send and receive emails from internet using front-end transport service, which resides on Exchange client access server. Front-end transport service does AD lookup for closest healthy mailbox server to connect with transport service in the same Active Directory site for the message transfer, regardless of number, type, or the location of the message recipient. All right. So it's very simple. For the client access server, it will be trying to connect to the mailbox server and trying to deliver the message to transport service of the mailbox server. All right. So front-end service, front-end transport service only proxies incoming and outgoing. Front-end transport service also runs connection filtering, which is which you can enable. We'll see the steps later in the presentation, but somewhere it might not be supported, so we'll have to check Microsoft recommendation before enabling it, but there's a way you can enable it. Alright, so on the mailbox server, transport service resides where SMTP receive accepts the email and does the categorization, routing, and then sends the email. Point to note that you can see store driver has moved out of transport service, which was there in Exchange 2010. Alright, the transport service can directly deliver the message to any mailbox server mailbox transport service. So that means that transport service will receive the message from front-end service and then look for the local mailbox transport service, which is the local to the mailbox database, and deliver the message there. So transport service to transport service, it will not go. Transport service to mailbox transport service, it will go to different server as well. Alright, so on the mailbox server, we also have mailbox transport service, which receives the message on the SMTP receive under the mailbox transport service, and then it delivers the message to the mailbox database. Alright, similarly, mailbox transport submissions service under mailbox transport service picks the message from outbox, then select any mailbox server transport service which is closest within the same AD site. Alright, basically mailbox transport service also proxies then email. Alright, So it's similar to the front end transport service, which also proxies, doesn't do any intelligence of its own. Um, just forward it to the transport service on the mailbox server. All right. So the mailbox transport service on the mailbox server is the broker between the transport service and the mailbox databases. The mailbox transport service communicates directly. I'm not sure whether can we all see the slide? I'm still on the same slide. All right. So all right. So yeah, it works as a broker between transport service and the mailbox databases. The transport service communicates directly with the local mailbox database using RPC with the transport service on the local and remote mailbox servers using SMTP. So let us understand about the services and ports of Exchange 2013. All right. So front-end transport service runs on all client access servers and act as a stateless proxy for all inbound and outbound SMTP mail flow. The front-end transport service does not inspect message content, only communicates with the transport service. So front-end transport service runs on all client servers and act as a stateless proxy for all inbound and outbound SMTP mail flow. The front-end transport service doesn't inspect message content, only communicates with transport service on a mailbox server, and does not queue any message locally. Alright. The front-end transport service receives emails from internet on port 25 and 587 and from mailbox server on port 717. So you can see the mail is coming from the top, internet from the client, or from any other external SMTP server, and it's from the client it's receiving on port 587 and from the external SMTP server on port 25. While the mails are going out, it can receive the email from transport service on port 717. All right. I'm sorry. 717 is the port for front-end transport service. So this is gonna yes. It doesn't queue up. I mean, front end doesn't queue up anything. That's for sure. We just have queues. Yes, it's just proxies. All right. So front-end transport service also sends outbound emails if send connector is configured to route outbound mails through client access server. We'll see in the next slide how to configure it. All right. So if client access and mailbox server roles are separate on different server, then edge transport bypass the client access service, applying client access server, and communicate directly with the transport service on the mailbox server. Now you know that we have Microsoft has released a Service Pack 1, and with Service Pack 1 we can install Edge Transport Service. You can have a look on my blog for the Edge Transport Service installation steps. Edge Transport Server installation steps. I'm sorry. All right. Now transport service. So the transport service run on all mailbox servers. It is identical to Hub Transport Server role in the previous versions of Exchange, like Exchange 2010, except the store driver, as I said. The transport service manage the queue for all SMTP mail flow, perform categorization, routing, address rewriting, message content inspection, generaling, right management, um, transport agents, DLP rules, transport rules, right management policy and rules. Everything runs on the transport service. All right. So this is the transport service is the intelligent all of these service. Um, Other services are just the forwarders, so kind of a dumb service, as you can say. All right. No, transport service is on the mailbox server. The service in the middle, you can see. All right. So transport service. Okay. So unlike the previous versions of Exchange, transport service does not communicate to the mailbox database. All right. Uh, then transport service runs the malware agent, which is enabled by default in the transport service on all mailbox servers to help protect organization from malware and other unwanted contents. Sorry. All default anti-spam agents will run on transport service. By default, they come disabled, but we can enable by running the commandlet script, which is in the script folder of your Exchange 2013 installation. The script is install-anti-spam agents.ps1. The transport service routes messages between mailbox transport service and the front-end service, the front-end transport service. Transport service receives the message on port 25 and 465. So mostly the traffic on 465, which is coming from incoming, is the traffic which we receive on 587. That will be coming to 465, and port 25 is just a port 25 proxy, and port 25 traffic will also be the coming from, it can come directly from the other external SMTP servers. All right. So when CAS and mailbox servers are on the same server, the transport service uses port 2525. That you can see if you have a multi-role installed. The connector on the mailbox server role will be using port 2525. There's no harm in using it. We can definitely use it. It is very simple. Why we have to use port 2525 is because two SMTP services cannot run on the same port. Similar to the web services, you can see the web HTTP service which runs the website for ECP. If you have a multi-server role, you can see the port 443 it uses for the CAS, and then 444 for the mailbox server. All right. So port 465 is also important for submission, for mailbox transport submission service. So mailbox transport submission service picks it from the mailbox, picks a message from the mailbox and forward it to port 465. This content you will not find anywhere, that I can tell you. Mailbox transport. Next service is the mailbox transport service. This service runs on all mailbox server, which is consist of two separate service: the mailbox transport service, submission service, and mailbox transport delivery service. The mailbox transport delivery service receives SMTP message from transport service on the local server or on other mailbox servers and connects to local mailbox databases using Exchange remote procedure call RPC to deliver the message. The mailbox transport submission service connects to the local mailbox database using RPC to retrieve messages and submits the messages over SMTP to transport service on the local mailbox server or on the other mailbox server. So it can give the message to the local transport service, or it can give the messages to the other server's transport service, which is very important. It can find any healthy transport service and give the message to that service, not necessarily on the same server. The mailbox transport submission service has access to the same routing topology information as the transport service. Like the front-end transport service, mailbox transport service also doesn't queue any message locally. The mailbox transport service receives the email on ports 475. So when the transport service forwards the messages, the mailbox transport service receives the messages on port 75. Basically, the mailbox transport delivery service receives the messages on port 75, port 475. All right. Let's have another look, another review on the ports, just to recap on the ports. So the ports the transport service uses are 25, 25, 25, 587, 717, 465, and 475. So port 25 is known as SMTP port, which is used by both external SMTP to send emails to front end, and also the front end transport service to the transport service, unless together on the same server. All right. So front end transport or transport service use port to send outbound emails as well. All right. So port 587, let's take port 2525 before. So port 2525 before, if the cache and mailbox servers are together on the same server, the transport service will listen incoming emails on port 2525 instead of 25. This is because both the services cannot use the same port. Next is the port 587. The port is used for client connection, POP/IMAP, which receives the emails on the CAS front-end transport service. Port 717 is used for outbound proxy connections from transport service to front-end transport service. When you create a send connector, you have the option to send mail destined for the internet directly from transport service to internet or the smart host. That mail go through, you have an option to configure the front-end transport service. So if you relay through front-end transport service, then front-end transport service receives the email on port 717 from transport service. Port 465 is used to accept proxied connections that were received on port 587 by front-end transport service for client connections. The transport service also receives message from mailbox transport submission service on 465 port. Port 475, the mailbox transport service listen on this port for connection either from transport service, SMTP send, or SMTP from transport service on other mailbox servers that needs to send mail to the users on this server. Very clear. All right. So let's move on to the next slide. This is the pretty much architecture and the transport service and the ports in the Exchange 2013 transport. All right, so let's understand the mail delivery. How does the mail delivery work in three different scenarios? Okay, so if you we are on the next slide, which is the mail delivery slide. If you are not, just change it. All right, so let's take the question at the end. All right, so so mail delivery. So the first scenario, if the email is coming from internet, how will it deliver to your mailbox? So mail is coming from internet on port 25 because it's a universal port. It's as per the RFC, we have to use port 25 over the internet, otherwise it will not work. So everyone uses port 25 to receive the emails. So the email comes from internet to spam guard. You might have some spam guard like Barracuda, Ironport, Edge transport server, or any other kind of a spam guard. There are so many. So that will receive the on the port spam guard. Then the spam guard will forward it to a front-end service on port 25. Then front-end service will transfer the email to transport service on 25 or port 2525 if they are together on same server. Then email will be forwarded to mailbox transport delivery service on port 475 of the local mailbox database, and mailbox transport delivery service will transfer the message to the database, and then you will connect and access it. The mail flow scenario 2, when you send an email out to the internet, how does it happen? So mail comes, you have the email in your database, mailbox transport submission service picks the email on port 475 and transfer to the transport service on 465. The transport service transfers to the front-end transport service on 717. Front-end transport service transfers the email to spam guard on port 25, and then spam guard transfers to internet on port 25. Alright, so the third scenario is talking about how the internal mail flow works. Alright, so if you have a message on the server 1 and you're trying to send an email to the database which is active on server 2, I'm considering a DAG scenario because everyone is implementing DAG for the high availability. So the mail from server 1 will be picked by mailbox transport submission service, and it will be transferred to the transport service on any of the DAG server on port 465. It will be given to any of the transport service on any of the mailbox server, and then transport service will forward the email to the local transport mailbox transport delivery service on 475 port on server 2, and server 2 will deliver to the store mailbox database. Alright, so these are the three scenarios which covers most of the environment of Exchange 2013. Exchange 2013 has come up with few new SMTP verbs. These are from if you use front-end transport to transport service, it uses X proxy from, and then when transport service to front-end transport service, it's X proxy to. So X proxy from and to carries the message information, that from where it is coming, so all information about the header, so that it should not be it should be able to categorize properly. Alright, then we have a couple of more verbs which Exchange 2013 uses from transport service to mailbox transport service. These are X session perms, which carries all session parameters, and X message context, which carries special or specific context of the message. Alright, so let's move on to the next slide. Next slide is talking about the receive header. I'm giving an example of the receive header. If the message comes how the receive header will look like. So let's read it from the last header. So last header will be, that's the way we have to read it. So last header is the first header which adds to the mail. So it's a subject, message ID from, and then the second header is the front-end transport service received it, and from where it received it. The third header is telling us that the mailbox transport service, third header is telling that the mailbox role server received it on the transport service, and from which client access server it received it. And the fourth header is telling mailbox transport service received it from which mailbox role server. It can be same, it can be different, right? This header also telling us the Exchange version. So in my lab, from where I picked it, we are using 15.0.775.38. I think it's Service Pack 1 version. Alright, so it also carries the message ID, so you can trace it as per the message ID. Alright, so let's move on to the next slide. Now we're going to talk about the transport connectors. The transport connectors are at the 3 level of Exchange 2013. So the first is the org level. The org level is the send connector, which we use for sending the emails outbound, so to send the emails out, and the remaining are to function differently, to receive it, basically, not to send, basically to receive the email and then they forward it using send connector. So you can see the this screenshot. There is an image which is showing on the right end. There's a checkbox which is unchecked, saying proxy through client access server. So if we check this checkbox, then the outbound proxy front end connector comes into the picture, and the front end transport service uses this connector and then sends the email using send connector. Alright, this is the checkbox I talked about earlier. So moving back to the transport connectors, the client access server uses 3 connectors. Default front end, so transport for receive and forward the messages to mailbox mailbox server for transport service. Then outbound proxy front end server receives the email to send through send connector to send it outbound to the internet or any other external SMTP server. Then client front end 587 port, it receives the email from the clients like POP and IMAP. Then we have mailbox server, which has 2 connectors. Default connector receives the emails on port 25. If it is separate from CAS, if it is multi-role server, it receives the email on 2525. Then we have client proxy connector, which receives the email from mail submission service or from the client POP and IMAP from front end transport service. All right, let's move on to the next slide. So the next slide is transport high availability. Now we are moving towards the world where high availability is a need, because we cannot afford to lose the emails. So if we talk about losing of the emails, we had a good option of the dumpster, which was to protect from losing the email. But what if that server which has a dumpster goes down? We will lose all the emails, right? So Microsoft thought about it, that okay, we have the high availability on DAG, we have the high availability on the CAS namespace. So why not on the transport? Because transport is the main component why we use the Exchange server, is the messaging, right? So they worked on it, and they found a very good alternative. We'll talk about it in the next slide. So the new transport high availability works with DAG and non-DAG, both environments. So in the DAG environment, it's the DAG will be the transport boundary, and it can go to any number of sites in terms of high availability. But in the non-DAG environment, it will be restricted to the 80 site. So if the 80 site goes, you cannot recover those messages. But in case of DAG, if you have configured a DAG, then you can definitely recover those messages. Then we have site resiliency, which means that you can definitely go beyond one site. So new transport high availability provides going to different sites and still be able to recover. It's more reliable. So time-based. This is time-based service. I mean, we can configure a time after number of days the this high availability can remove those high availability messages, but there's no size limit, we can say. Right, so it automatically recovers, which is a great thing. You don't have to do anything, it's going to recover automatically. So that is for the system administrator. There's nothing much he is supposed to do. You just sit quiet and enjoy the Exchange 2013 features. All right, the new verb which has come is Exchange Shadow, which is the part of the high availability. So this is the new verb where we can see on the right side of the slide. It's one of um, the verbs output I got from Exchange 2013, which shows we have a new verb called X shadow. It is talking about the shadow redundancy. We'll see in the next slide. All right. All right. Shadow redundancy and safety net. So shadow redundancy is almost similar to Exchange 2010. Shadow redundancy sends acknowledgement only after making shadow copy. If shadow copy of a message is successfully created, but SMTP session between the sending SMTP and the primary server times out, the primary server accepts and processes the primary message. The sending SMTP server will redeliver acknowledged message, but duplicate message detection will prevent Exchange mailbox users from seeing the duplicate messages. All right, isn't it good? It's kind of a brain working. It's kind of a sensible high availability. So shadow redundancy works for both DAG and non-DAG. For DAG, it's a same. It's a DAG is a boundary, and non-DAG, it's Active Directory site is a boundary. By default, shadow redundancy is enabled, so we are good. Let's talk about safety net. Safety net creates the queue on the transport service. So you will see some queues, but it's created by safety net. Safety net provides redundancy by redelivering the message in case of loss in transition. Safety net is no longer a single point of failure. This introduces the concept of primary safety net and shadow safety net. So if primary safety net is unavailable for more than 12 hours, the resubmit request becomes shadow resubmit request, and message are redelivered from shadow safety net. All right. In Exchange 2013, transport high availability is more than just a best effort for message redundancy. Exchange 2013 attempts to guarantee message redundancy. Safety net does not have any size limit, but number of days is the limit which we can set. I mean, that's number of days, how many days you want to keep the message in the safety net, even if it is even if it is delivered, it still be there. The safety net is automated and no manual effort required. So the active manager, if you remember, we have active manager in the DAG. So the active manager plays the part here. So the active manager delivers the message. All right. And all right, so let's move on to the next slide. All right, this is shadow redundancy workflow. We'll talk about it a little bit. So this is very simple. You can see the first server is the SMTP server on the left. So any external SMTP server is trying to send an email to our organization. That's the scenario. So in the first step, SMTP server, external server, sends a message to primary 2013 transport server, which is we're talking about the mailbox role server. It has bypassed front end server, or it has come through. So because it just proxies, so there's no connection. So it connects to the transport service on mailbox server, and the step number 2, you can see that it has created a copy on the shadow server right away. even before sending the acknowledgement. In the step 3, shadow server sends acknowledgement to the primary server, and in the step 4, primary server sends the acknowledgement back to the external SMTP server. So you can see, until we have the shadow copy done, Exchange 2013 does not send the acknowledgement of the receive of the email. So in case of the so when it is going to be doing the shadow redundancy, shadowing the message, if it is a DAG environment, it will do the shadow copy in the second Active Directory site and not on the same Active Directory site. This is by default. And in case of a non-DAG environment, it will definitely copy to the next possible healthy mailbox server. Alright, let's move on to the next slide, which is transport high availability workflow. So here comes the safety net as well. So a mailbox server receives a message from any SMTP that's outside the transport high availability boundary. The transport high availability boundary is a DAG or Active Directory site on a non-DAG environment. Before acknowledging the receipt of primary message, the primary mailbox server initiates a new SMTP session to shadow mailbox server within the transport high availability boundary and makes a shadow copy of the message. In DAG environment, a shadow server in a remote Active Directory is preferred. Then in the step number 3, the primary server processes the primary message and delivers it to users within the transport high availability boundary or relate to the next hop. The primary server queues a discard status for shadow server that indicates the primary message was successfully delivered, and primary server moves the primary message into the local primary safety net. So you can see that's moving to the primary safety net, which means it has not discarded the message. It is still there and going to stay until the limit we have configured. In the step 4, the shadow server periodically polls the primary server for discard status for the primary message which it receives this time, and in the step 5th, when the shadow server determines primary server successfully delivered the message, delivered the primary message or related to the next hop, the shadow server moves the shadow message into the local shadow safety net. So both the servers, now the message is there in the safety net and waiting for the safety net expiry. So in this step 6, the message is retained in the primary safety net and the shadow safety net until the message expires. The moment it expires, it deletes the message. That's how transport high availability workflow works. Alright, next slide is talking about an example of the safety net. We can see the first inbound email comes from external SMTP to mailbox 01 server. In the second step, shadow redundancy duplicates email to mailbox 03 server and delay acknowledgement. You can see this most important is the delays acknowledgement. In the step 3A, you can see mailbox 01 server deliver the email from transport service to mailbox transport service. In the step 3B, you can see mailbox transport service delivers the message to the local mailbox database. In the step 3C, you can see mailbox 01 server queues discard status for mailbox 03 server for successful delivery, and mailbox 01 server moves emails into local primary safety net. In the step 4, mailbox 03 server periodically polls mailbox 01 server for discard status of primary copy of the email. In the step 5, you can see mailbox 03 server determine mailbox 01 server successfully delivered. Mailbox 03 server moves the shadow message into the local shadow safety net. Alright, this is very clear to you. Let's move on to the next slide. Now we're going to talk about the routing. In Exchange 2013, uh, we have delivery groups, which is a way to generalize mail routing to help improve efficiency and attempt to deliver a message as close to its destination as possible. A delivery group could be a DAG, mailbox delivery group, connector source servers, hub sites, edge subscription. So subscription is only to the servers which you have which subscribe the edge. So edge will deliver to those servers only. That's another delivery group. The DL expansion server. The DL expansion server is not recommended. I will never recommend to configure a DL expansion server, because if this server goes off, then your DL will not be expanding anymore. You will have to configure it back, but the options are available, right? So final delivery is the mailbox transport service to store. So the at the local store server where the mailbox database is active, the local mailbox transport service will receive the message and deliver to the store. So the preference is local mailbox server for the connectivity. Anytime you will see that it will try to connect to the local and the closest mailbox server to deliver the message. Bifurcation. So the bifurcation of the message is the routing decision, which tells at what level we have to create multiple copies of the email. So let's say you have sent an email to 10 users, 5 of them are in your same organization, and 5 of them are outside organization. So Exchange will take the message together until the last destination, till the time it's part of the Exchange org. The moment it's going out of the Exchange org, it will bifurcate the messages, or it will bifurcate the messages at one level where mailbox transport service is going to deliver the it will bifurcate the message when the transport service is going to bifurcate the message to mailbox transport service and the send connectors. Depends on the configuration, where if you have a hub site, then every message will go to hub site and then redeliver. Then it will deliver and it's bifurcated. All right. How it takes the routing decision? That's route calculation. The first thing Exchange 2013 is look for the minimum cost, which is configured on the Active Directory, site links. You can also configure Exchange cost, but the first thing it checks for the cost, and then if 2 or more servers have the same cost, so 2 or more site links or routes has same cost, then it will look for the minimum hops. If 2 or more route has same cost and same hop, then it will go for the alphanumeric name of the Active Directory AD site. All right, let's move on to the next slide. So connection filtering, which doesn't come along with the install anti-spam agent.ps1. Here are the steps which you can follow to install connection filtering. So open the Exchange management shell as administrator, then run this command, install transport agent. It's a full command, one command. Then set the proper order of the transport, which is like first should be the connection filtering, so that connection filtering can discard the connection if it's coming on your server from a spam expected server. Then after setting the correct order, we can add an IP block list provider by running this command, add IP block list provider. Then we can enable the transport agent by running the command enable transport agent. Once you enable it, restart the front-end transport service. So remember, we have to run this on the client access server. It might on the client access server, if you see some issues in running an Exchange management shell, you might need to run it from PowerShell. All right, let's move on to the next slide. All right, we are close to our close to close our session. So today, in today's session, we'll learn about transport architecture, mail flow, transport high availability, transport connectors and services, transport ports. All right. So this is about me. You can send me a feedback. I blog on mxsectionguru.com. It is just not me. In fact, we are a couple of MVPs, the most valuable professionals, as well as a couple of other Microsoft PSS colleagues who write the blogs there. So you'll find good skilled people there and answering your queries. We answer good. We find some time to answer you. You can follow us on Twitter, Facebook, YouTube, LinkedIn groups, and I would like to thank you for joining my session, and we can take the questions now. In the event of the outage, SafetyNet will automatically redeliver it. So it's an automated process. Oh yeah, I mean, okay. From the learning point, okay. So from the learning point of view, yeah, I just email me. You have my email address here. Just email me. I will definitely send you some URL, some links.